Okay, the next thing is the behavior near asymptotes. So what behavior means is basically what the shape of the graph looks like, or how the function is going to look like near its asymptotes. So this includes our vertical asymptotes, our horizontal asymptotes, or oblique asymptotes. Yep, so whichever one we have. And so basically how we get to do this is for our asymptotes, we're going to start with the vertical ones. The vertical asymptotes are functions, always go all the way up like this, or all the way down on either side of the asymptote. So for our vertical asymptotes, on the left side, either goes up or down. Also on the right side, it also goes either up or down. So when we analyze the behavior, we're trying to figure out on either side which one it's going to be. Is it going to be on the, is it going to shoot up like this, or shoot down like that on the left, or on the right, is it going to shoot up like this or down like that? Similarly, for our horizontal asymptotes, our function gets really close to the horizontal asymptote, so we have to figure out on the right side, or when we get to positive infinity, is our function going to shoot down like this way, or is it going to come up like this? Similarly, when x is going to negative infinity, is our function going to shoot this way above our horizontal asymptote, or is it going to come from below our horizontal asymptote? So for oblique asymptote, it's kind of similar in a sense. If we kind of draw our line like this, a diagonal line, we know that the function is going to get close to it, but is it going to shoot this way or this way when x goes to positive infinity? And is it going to come from above or below when x gets to negative infinity? So when we analyze behavior, we are basically figuring all of those things out. So yeah, let's start doing it. Let's erase this for a sec. Okay, so for vertical asymptotes, since we're analyzing on the left and right hand side, all we need to do is plug in a point really close to the asymptote on the left side and the right side of the asymptote. And basically what we're looking for is if we plug in a point on the left side and it is a positive number, then we know that's going to shoot up like this because it's positive. And if it's negative, it'll have to shoot down like this. So that's the whole goal. We're just substituting a point that's really close to the asymptotes and seeing if the outcome is positive or negative. So let's do that for this function, our example over here, just to show that. Okay, so f of x equals x plus 4 over 3x squared minus 10x minus 8. Let's get our vertical asymptotes. We have x plus 4 equals 2, 3x plus 2, x minus 4. Therefore, our vertical asymptotes, 2 over 3, and 4. Sweet. So our HA, let's just get our asymptotes. Since the degree top is degree 1, degree bottom is 2, our HA is going to be at 0. Nice. So after we get our asymptotes, let's get the behaviors. And we're going to teach you how to do that. So we're actually going to draw this little table here. This is actually something one of my students showed me. And it's actually a really good table. Props to, shout out to Veronica. If you're watching this, this is an awesome table. Thank you for showing me. Okay, and it's a great way of getting the behavior. So let's start off with getting the behavior for our vertical asymptotes. Okay. So the first one is -2/3. So if you imagine our function is going to have an asymptote when x equals to 2/3. If we want to find out whether or not it shoots up like this or down like that, what we can do is we can substitute a point that's really close to -2/3 on the left side of it. And the idea here is we're just going to figure out whether the result is going to be positive or negative. And that's all the information we need, because we know it's either going to shoot up like this towards positive infinity, or it's going to shoot down over here towards negative infinity. So if you want to find out which one's going to be, all we need to do is figure out if our function is going to be positive or negative around that point. So let's do it. Okay, so if we substitute a point near -2/3, let's say, that's like -0.7. Let's substitute it into our function and see what we get. Okay, so what I got was 7.02. Alright, so that means that because we have something positive, we know that our function is going to shoot up like this on the left side of -2/3. So it's not going to look like this, it's going to look like that. There we go, and that's how you do it. We can just repeat the same process, but choosing a number on the right side of the asymptote to get our behavior on the right side of it. So something that's on the right side of this would be like -0.6. So let's substitute that into our function, see what we get. Okay, so substitute into our calculator, the result we have -3.7 around. It was like 6.9, -3.7. We don't care about the number, all we care about is that it's negative. And that's going to tell us that our function is going to shoot down like this towards negative infinity on the side of the asymptote. Sweet. So the way we write this out is, there's a proper way of writing this out using our table over here. So as x approaches 2, -2/3, and we use a negative sign at the very top to say from the left, so from the left side of our asymptote, as x approaches to -2/3, from the left side, it goes to positive infinity. And from the right side of it, instead of using a negative sign, we use a plus sign. We say it goes to negative infinity. Okay. So yeah, there we have it. That's for our first one. So let's go ahead and do our second one. So our second asymptote that we have is at x equals to 4. So we can do the same thing. All we have to do is substitute a point on the left side of 4 and on the right side of 4 into our function and see if it's positive or negative. So something that's close to 4 on the left side is 3.99. So let's do that. 3.99. Okay. So right now I'm actually going to show you another way you can find out if it's positive or negative without having to use a calculator. You can actually just use your brain for a little bit and you can figure it out. So here's how we do it. So if we have our function here and it's factored, we're going to just imagine plugging in 3.99 into each one of our x's, and we're just going to figure out all the brackets if each bracket is positive or negative. So let's do that. So if we sub in 3.99 into our function, our thing at the very top is going to be something positive. Right? It's like 7.99, something positive. If we substitute it over here, this bracket becomes a positive number. It's like 3 times a positive number, 3.99 is positive. And we're adding another positive number, so it's also positive. Okay. And then once we sub in 3.99 into this one, this guy is going to become negative. So since we have a positive, divide by a positive, which is positive, divide by negative, which becomes negative, this whole thing is going to be negative, so we know that this guy is going to go to negative infinity. Okay, and also the next guy, you can do the same thing. So point that's very close to 4 on the right side of our asymptote is 4.01. My writing is very shoddy right now. Alright, it's fine. Okay, so let's do the same thing. If we substitute 4.01, the very top is going to be a positive number. This factor over here is also going to be a positive number. It's okay if you don't know exactly what it is. All we have to do is use our number sense and figure out if it's positive or negative. We sub in 4.01 into this bracket. This whole thing is going to become positive 2. Since we have a positive, divide by positive, divide by another positive. We have 3 positives here. All of them are positive, so this guy's going to shoot up to positive infinity. Sweet. So if we kind of imagine what it looks like, if you try sketching it out, on the left side, it's going to shoot down like this. On the right, it's going to shoot up like that. Okay. So let's write it out. So as x approaches 2, 4 from the left. So that's from the left over here. It's going to go to negative infinity. And the other one's going to shoot up to positive infinity. So when x is approaching to 4, from the right, it's going to shoot up to positive infinity. Okay. Hopefully everything's good. Okay. So we don't have much room in our table here. So what I'm going to do is going to erase this part. Okay. Make it slightly neater to make room. Okay. So let's do a horizontal asymptote now. So we are going to erase this. For horizontal asymptote, the idea is very similar to the vertical asymptote. We know that when x is approaching to positive infinity, it's either going to come from above like this and approach it from above, or it's going to approach the horizontal asymptote from below. So all we have to do is we can just substitute a number that's extremely big, very close, like a positive, extremely big positive number. And if the number is slightly bigger than our horizontal asymptote, then it's going to be coming from above. And then if our result is slightly less than our horizontal asymptote, then we know it's going to come from below. So let's do it for this example. So what we're going to do is substitute like 1000 into our function over here. So if we substitute 1000, we are going to get some number. Let's figure out what that is. So what I got was 0.00034. 0. So I'm going to write it out. So it's 0.00034. So what this means is our function must be approaching our horizontal asymptote from above when x is going to positive infinity. Alright, and then we can do the same thing for the other side of our horizontal asymptote when x is approaching to negative infinity. So all we have to do is substitute in a really big negative number. So that would be like negative 1000 and see what we get. Okay. So what I got was very similar. I got negative 0.00033. You don't really care that it's not what it is, but it is negative. So we know that when x is approaching to negative infinity, whatever is happening here, we know that it's going to approach the horizontal asymptote from below. It'll look like that. Okay, so we can write our result in a little table here to organize it. So as x is going to positive infinity, oops, it's going to positive infinity, our function approaches 0 from above. And the way we write that is with a little plus sign. Makes sense because it's slightly positive. And then when our function, when x is approaching to negative infinity, it's gonna be coming from below. So let's imagine all of this stuff on our graph. So we're gonna put this all together, try and imagine what it looks like. And then we're gonna go to Desmos, graph it, and see what it looks like. So first we have our dA, x equals 2, negative 2 over 3. And then we have our other vertical asymptote, whoops, at x equals to 4. Okay, I'm gonna fix this up. For some reason it became a y. Okay. Negative 2 over 3. Okay. We got our horizontal asymptote. So we're just gonna put it all together right now. So we know that when x is approaching to positive infinity, our function is gonna come from above and approach 0 from above. So we know our function is going to go like this, going to go down like that. And if once x goes to negative infinity, it's coming from below. So we know that it's going to look something like that over here, coming from below. Okay, that's there we go. Okay, I don't want smart drawing on. It's causing some issues here. Okay, and then when x is approaching to negative 2 over 3, from the left, it's going to positive infinity. Okay. Right, and then when it's going to positive infinity, going to negative 2 or 3, from the left, it's going to positive infinity, so we know that. So we should put like this. And then when it's coming from the right, it's going to go down to negative infinity. And then we can just draw the rest like this. So coming from the left, it's going to negative infinity. Right, it's positive. Yeah, so behavior is actually extremely powerful in graphing rational functions because you can already tell kind of what the shape of it looks like. So this guy, it kind of looks like these guys would connect together like this. And then these guys would connect together like that. And here it's a little weird because it's coming down from here, but also has to shoot back up. So what this actually tells us is that it's actually going to loop up over here. And then we can actually use other things like crossover points that we're going to learn later to prove that it actually does do this. That actually does go all shoot, like it's going to go like this, and then it's going to turn around and shoot all the way back up. But let's go to Desmos to confirm that these are the behaviors that were. So our function was x plus 4 over 3x squared minus 10x minus 8. Let's put our vertical asymptotes in. X equals to 4. Alright. So it doesn't look like this part of our graph is right, but these guys are. But if you kind of look over here, you kind of see that our function does cross our x-intercept, and it's actually approaching our horizontal asymptote from below, as we got earlier. So it doesn't look like it curves all the way down like this from our before, but the whole point is it does approach from below. It does slightly curve down like this. You have to trust me on this. It slightly curves down like this, and then around this area is when it kind of comes all the way back up. It crosses it and shoots all the way up over here. So yep, it does look like this. It does look like that. So that's how you get behavior. So we're actually going to do another example. This time not doing the vertical asymptotes, but we're going to show you how you can get behavior for horizontal asymptotes and oblique asymptotes that are not zero. Those are slightly weirder. So we're going to do another example, but just do the horizontal / oblique asymptote. Okay, so we have another function here, 2x minus 4 over 3x minus 1, and we're just going to analyze the behavior near its horizontal asymptote. So right now we can already tell, because this guy is degree 1, this one is also degree 1. Since they have the same degree, its horizontal asymptote is not going to be at 0. It's just going to be the leading coefficient, which is 2, divided by the leading coefficient of the bottom, which is 3. So our HA, that's equals to 2 over 3. Alrighty, good stuff. So the process is exactly the same, just like before. We just have to figure out if our function is going to come from above the horizontal asymptote, like this, below the horizontal asymptote. Similarly, from the other side, is it going to come from above or from below? So just like before, we can just substitute like a really big positive number or a really big negative number. But instead of looking at whether or not it's positive or negative, we just have to figure out if it's slightly bigger than 2 over 3 or slightly smaller than 2 over 3. Now, that way, if it's slightly bigger than 2 over 3, we know that it has to come from above. It has to come from above the horizontal asymptote. Or if it's slightly smaller than 2 over 3, it has to come from below. It's got to approach the horizontal asymptote from below the horizontal asymptote. So let's do it. Let's sub in 1000. Okay, so when I subbed in 1000, the number I got is 0.6655. And since 2 over 3, if we change it to decimal, is 0.66666 repeating, this guy is smaller than 2 over 3, which means that when we approach x to positive infinity, since we subbed a really big number, it's going to approach the function from below, like that. So let's do the same thing for negative 1000. Alright, so when we substitute negative 1000, the number I got was 0.6677, goes on for a bit. Since this number is slightly bigger than 0.6666 repeating, 2 over 3, you know that as x approaches to negative infinity, our function is going to approach the horizontal asymptote from above, like that. Alright, so there you have it. So we can write it out like this. When x approaches to positive infinity, our f of x approaches to 2 over 3 from above. Similarly, when it approaches to negative infinity, our function approaches to 2 over 3. Oh, wait, messed that up. It's the other way around. This should be from below, which is a negative sign, and approaching to negative infinity should be from above, like that. Okay, so let's take a look at the graph on Desmos, just to confirm that this is true. So let's graph this guy. Okay, so let's input a function. 3x minus 1. Our horizontal asymptote is 2 over 3. As you can tell, our analysis is good, it's sound. When x is approaching positive infinity, our function is approaching to our asymptote from below. It's shooting up like this. And when it's approaching to negative infinity, our function is approaching our asymptote from above. Alright, so yeah, that's how you do it. Okay, so let's graph this. 2x minus 4, and then 3x. Okay, y equals 2 over 3. So you can already see that our analysis is sound. As our function approaches to negative, positive infinity, our function approaches the asymptote from below. It goes all the way down like this. Similarly, when x is approaching to negative infinity, so when we approach negative infinity, our function approaches the asymptote from above. It goes like this. And yeah, that's it. That's how you do it. So let's do the last example where we figure out behavior for oblique asymptote. It's slightly weird, but very similar to what we did here. Okay, so let's do that for our OA here. So this function, has an oblique asymptote because the degree of the top is 2 and the degree of the bottom is 1. So because the degree of numerator is bigger than the bottom, it's going to be oblique asymptote. So what we're going to do is we're going to long divide and we're going to get our oblique asymptote over here. So let's get it. Synthetic, please work. Okay, 2, -1, -4. Just going to do this pretty fast. Okay, so what we're going to do is we're going to write out our oblique asymptote, and we're going to actually write our function in its remainder form now. So it's quotient plus the remainder over the denominator, which is x plus 1. We're going to write our function like this. Minus 3 plus -1 over x plus 1. So from what we know about OAs, this guy is going to be our oblique asymptote, 2x minus 3. So kind of draw this out. Just like before, all we have to do is figure out if it's approaching above our OA or from below. When x is approaching to positive infinity and when x is approaching to negative infinity. So we have to figure out for both directions. So the reason why we wrote it out like this is we can actually tell very easily by this guy over here. So our function is basically 2x minus 3, but we're just adding this little small term over here. And this term is going to help us a lot. All we have to do is we can sub in 1000 just like before, but instead of subbing in 1000 to the entire function, we're just going to substitute it in here. And we're going to see what happens. So let's do it right now. So if you sub 1000 just into this guy, what we get is -1 percentages to what? 1000 plus 1 equals to -1 over 1001. So what we get over here is a very small negative number. But since we're adding 2x minus 3 with this very small negative number, we know it's going to be slightly smaller or slightly below this line. So that means that when x is approaching to positive infinity, we know that the line will have to come from below the OA. It has to come from below over here. Now, since we're taking 2x minus 3 and we're subtracting a very small fraction, the function is going to be slightly below the OA over here. So we know it's going to be going like that. That's it. That's the logic. You just have to sub in 1000 over here. If it's a negative number, then we know it's going to come from below. Conversely, if it becomes a positive number, you know it's going to go from above. So let's substitute negative 1000 and figure it out for this side of the OA. So we substitute negative 1000 into this guy. What we get is negative 1 divided by negative 999, which simplifies to positive 1 over 999. Since it's a positive number, that means that this guy is going to be slightly larger than 2x minus 3 when x is approaching to negative infinity. That means that our function will approach our OA from above. We'll go like that. And that's it. That's pretty much the gist for finding behavior near OAs. This is all you have to do. Just substitute 1000, but instead of substituting 1000 into your entire function, just substitute it in this small term over here. And if it becomes positive, then we know it's approaching from above. If it's negative, it's approaching from below. And we can do it for the other side too. So substitute negative 1000 or any number very big negatively and see whether or not this guy becomes positive or negative. So let's go to Desmos and confirm this. So let's substitute in our function. So you have 2x squared minus x minus 4. Oops, all over x plus 1. Alright, so we have this neat little thing. It's to our oblique asymptote. Okay, let's change this to black so we can see it clearly. So as you can see, our analysis works. As x approaches to positive infinity, notice our function approaches our oblique asymptote from below. And then when it goes to negative infinity, it approaches from above. So yeah, there we go. That's how you figure out behavior